Hey there, students. On this clip, we're going to be going over an example on how to use the the TI-83 calculator to solve systems graphically. Okay, so let's consider the following problem. You can write this down. Instructions are as follows. Um, solve, solve the given system of equations by graphing. Okay. Most of you might be able to do this by hand, but you might want to check your work using the calculator. So in this example, I'm going to show you how to solve an example where the both equations are in slope-intercept form. Okay, so in this case, we have squiggly bracket y equals negative 3x plus 5 and y equals x plus 1. All right. So how do we solve this by graphing using our calculators? Alright, so here we have a TI-83 calculator. Let me go home, credit page. So if you want to graph it, you're going to have to enter these two graphs in the graphing menu, and then you're going to calculate the intersection, okay? So whatever the intersection is, the x and the y values will be the solution to your system of equations. So what do? First thing we do, you see this button right here, this Y button? It takes you to the menu where you can enter your functions, all right? So press Y, and then you have a whole list of uh, spots to enter your equations, all right? We have two equations here. Remember, in order for you to enter your function into the graphing menu, they have to be solved explicitly in terms of Y, or they must be in slope-intercept form, okay? So you know what the slope-intercept form is. The slope-intercept form is basically the form where you have y equals mx plus b. Okay, so this is your slope-intercept form. Slope-intercept form. If your equation is in standard form or point slope form, you must transform it into slope-intercept form first before this calculator can be able to graph it. We have other powerful graphing calculators that can graph functions regardless of whatever formulation it's in. But this one, you have to put it in slope-intercept form, or you have to get y by itself first before you can use this calculator to do it. Okay? So this example is easy because y is already by itself in both cases, so we're going to enter it. Alright? So negative 3x, please do not use this minus right here. You see that? That would generate a syntax error. This is negative, so we're going to use this point right here, this sign, this minus right here next to the period. Okay, so negative, it's smaller than the other big minus right there, alright? So use a negative 3. You see this value right here is the variable. Whatever mode you're using, all these variables kick in. So since we're in the graphing mode right now, if I press mode, we see we have function, right? So you have to be on the function menu in order for it to show you y. Okay, so since we're in the function menu, this button automatically becomes x. Okay, so we have negative 3. Let me do it again. So we have negative 3, and then you press this button right here. The default value is x plus 5. Alright, enter. So there goes your first graph. And then for your second graph is just simply x plus 1. Enter. Alright, so you have these two graphs. You see this equals sign right here? If it's highlighted, that means it's active, okay? If it's not highlighted like this, that means it's not active and it's not going to be graphed. Alright, so let me highlight it again. So these are the two graphs I want to graph. Alright? So I'm going to press the graph button. Yeah. And there goes the first one, the one with the negative slope, and there goes the second one. Alright, so there goes your graph. Now we need to find the intersection. There are a whole bunch of things we can find here. But we're looking for the intersection because the intersection of two lines is a solution. So you see above trace, you have CLC calculate. This menu will help us calculate anything that we can calculate using this graph right here. So to access the calculation menu, you're going to press second function trace because we need this yellow function right here, which is calc. So second function trace will take us to the calculate menu. Alright, and what we need is the intersection. So you can scroll down to 5, or you can just press 5 it doesn't make any difference. Alright, so I scroll down to 5 and I hit enter. Now please pay close attention to what the calculator is asking you for so you don't make mistakes. So it says first curve. This is the first curve we have. If it is, press enter. Now you see the cursor has jumped to the second curve and it's asking you, is that the second curve? Because there might be more than 2 curves, there could be 3 curves. So the calculator is asking you which 2 you want to look for the intersection of so you don't get the answers mixed up. Alright, so it's asking you, is this the second curve? Of course, because we have only 2. Alright, so you press enter, and then it says guess. Guess? Oh yeah, absolutely. Press enter again, and then it calculates it and it tells you the intersection is x equals 1 and y equals 2. So guess what? That is a solution of your system of equations. So the solution is x equals 1 and y equals 2. Alright? Or you can write it as an ordered pair 1, 2 is your solution. If you want, you can do a check to see if our result is correct. It should be, right? So let's do a real quick check. So let's check the first equation, y equals negative 3x plus 5. I'm going to plug in 1 for my x and 2 for my y and see if I get a true equation or a true statement, alright? So the question is 2 equals negative 3 times 1 plus 5? Is it? Is 2 equals negative 3 plus 5? Is 2 equal 2? Absolutely, that works out. Let's take the next equation, y equals x plus 1. Question is 2 equals 1 plus 1? Is 2 equal 2? Absolutely. So you can see that our calculation and our whole procedure is actually accurate. Okay? So thanks so much for paying attention to this presentation. Feel free to subscribe to my videos so that you can get updates to new videos I release. And you can also request videos and share with your friends if you like this video. Collection of my clips can be found on math.serve.com. Thanks again and have a wonderful day.